Now, the ask of this particular question, rotten oranges, is that we have been given a grid where each cell is marked with 0, which is empty cell, 1, which is a fresh orange, and 2, which is a rotten orange. And now every minute, any fresh orange that is 4 directionally adjacent, which means up, down, left, right, to a rotten orange will become rotten too. So this is a classic multi-source BFS problem. So the key insight is that instead of running BFS from each rotten orange separately, you start the BFS from all rotten oranges at once by seeding the queue with every rotten orange at the minute 0. And then rot then spreads outwards in waves 1 minute per level. So the way the algorithm will work is that we will scan the grid once, on cue every rotten orange with a timestamp of 0 and count the fresh oranges. Then we perform our BFS, which means we will pop an orange, and for each of its 4 directions that is fresh, mark it rotten, decrease our counter for fresh, and then on cue it with minutes plus 1. And then we track the maximum minutes seen. So at the end, if any fresh oranges remain, which means they're unreachable, we return -1. Otherwise, we return the maximum minute. So going through the code line by line, we start over here, which means we get the grid dimensions. We have an empty queue that will hold rotten oranges to process. And then we also have a counter, so how many fresh oranges exist. Now we one pass over the whole grid, so every already rotten orange goes on the queue as a tuple. So row, column, and then minute. And then with minute 0, this is the multi-source part. So all rot sources start spreading simultaneously, and then every fresh orange just bumps the corner. So we pass with R, C, and 0. Now this minutes over here will track the latest time any orange got rotten. And then we have our directions, so up, down, left, right. Now this is the BFS part, which means we run until the queue is empty. So while the queue is empty, we pull the oldest entry, and that's what makes it breadth first, because oranges at minute 1 are all processed before any from minute 2. So we update minutes with the timestamp of the orange that we just pulled, and by the end it will hold the largest minute that we saw. And over here we are going through each of the directions, and then we are computing the neighbor's coordinate. So neighbor is new row and new column. And then we are doing 3 checks in just one line, where we are checking that the neighbor is inside the grid. So we are checking both the bounds, and then we are checking that's a fresh orange. And every empty cell, so 0, and any already rotten cells, so 2, are skipped. And then the neighbor rots, so we are going to mark it in the grid as 2. We will decrement the counter, the fresh count, and we on cue it with a timestamp 1 minute later than the orange that infected it. So we are adding +1. And now when the queue drains, the rot has spread as far as it possibly can. Now if fresh will hit 0, it means every orange has rotten, and your minutes is the answer. And if fresh is greater than 0, which means some oranges were unreachable, so you will return -1. And this is it.